Hi, I'm Colin McCarthy, and I'm a Senior Principal Engineer here at Amazon Web Services. I work on EC2 and Nitro and cryptography, and I'm here to do a deep dive into the AWS Nitro Enclave system, which we recently launched and made generally available. And I actually want to start with somewhere unusual, which is Amazon.com. This is what it looked like when I joined Amazon. If you used Amazon back in the 2000s, you might remember it. And since before AWS has existed, Amazon has a long history in securing people's credentials, particularly credit card numbers. We've got lots and lots of customers who are buying books or whatever else on Amazon.com, and we always have to make sure those credit card numbers are extremely well protected. And if you were to look inside at Amazon in the kind of 2000s era and see, well, how do we do that? How is it architected? Obviously we pay a lot of paranoid attention to just how secure our systems are, how secure our software is, but kind of underlying all that was a strategy of compartmentalization. So we had a production network, on our production internet accessible data centers that ran things like the front ends that were taking people's orders, and the back ends doing some processing, seeing what inventory was available, deciding which warehouse would handle your order and so on, and databases to keep all the state. And then we had a whole other world, another network just for handling payments and just for doing payments infrastructure. And so, whenever you added a credit card to Amazon.com, we'd get it into the payments network as quickly as possible, and then we'd issue it a token. And then for all future payments, we only refer to it by the token in the production network. And then we had this, slim, tiny little gateway between the two networks. And this compartmentalization was very intense. The payments network had very limited functionality. It was just there to do payments and payments things, which meant it was a very small size, very small surface area being exposed, basically just this API for, give me a credit card number, I'll give you back a token, or give me a token and how much to charge, and I'll go make that happen. But, had no internet access, and had no interactive access. In fact, if you had to do anything to administer the payments network, it was, deliberately very inconvenient. You had to go to literally a different physical space and use a different physical computer and, enter different passcodes and so on to verify that you should have access. Because we all knew that protecting that information is super important. And this strategy of compartmentalization, right? This just really let's have a very high level, strong split between sensitive data and the rest of our data and the rest of our processing is pretty common. And we actually see this today on EC2. So these days we have VPC, Virtual Private Cloud, which means you don't actually have to build physically separate networks and physically separate data centers like we did. You can do this virtually now. And we see lots of EC2 customers do this. They set up a public VPC that's internet connected, and, can handle requests, do whatever work customers need from it, and then keep the sensitive data, whether that's credit cards again, or health information, or, social security numbers or whatever, in a private VPC that's ring-fenced, and then have a very thin, straw between the two, this nice little firewall that keeps the surface area extremely minimal, but lets whatever sensitive data processing needs to happen. And it's a very successful pattern. But just looking at it, you can see there's a little burdensome. Right? You have to set up these explicit VPCs. You have to configure machines in one side or the other. You got to set up all the connectivity between them. And so the kind of overall mission of Nitro Enclaves is we want to be able to bring this level of security and this kind of compartmentalization all the way down to something you can do on a single EC2 instance, which gives you better agility, gives you cost effectiveness, and can also help with latency, right? If you're having to send requests between networks, you have to eat those round trips. But we can do a little better if we keep everything on the same instance. So the idea behind Nitro Enclaves, the clue is in the name, is we're creating these trusted execution environments, or secure enclaves that can do just general purpose computation. Just kind of like an instance. It can run any application, can run any kind of software you can put in there, but it's extremely compartmentalized, and it's its own little world where it doesn't have things like network access by default. And in fact, the security model behind all this, and the kind of threat model, it's an extremely robust one. And it's that even if the instance itself is compromised, right, or somebody gains unauthorized access to that EC2 instance, that the software and processing that's happening inside the enclave should still be safe, right? The instance can't read any of the memory that's in the enclave, can't see inside what's going on inside the enclave. It's just as if there's this wall between them, even though they're co-located, even though they're kind of physically on the same system. And this gives a lot of nice kind of really desirable properties. It's a way where we can provide customers with this secure, trusted environment. It's built on the protections of the Nitro system. I'll go into that and how this thing works. But it also provides like a very convenient and familiar model for development. So when you're using Nitro Enclaves, you don't feel like you have to do backflips to re-architecture architectures or applications to use this new enclaves concept. In fact, we've got all sorts of reference examples and open source code to help you get started. It's all pretty convenient. Even in the kind of short time since we've launched, we've already seen people build applications on top of enclaves, which is great feedback that it's usable and very practical. And we've kind of designed the product so that AWS takes on the burden of as much of the heavy lifting and cryptography and so on as possible. And we provide first-class integration with our cryptographic services, things like our key management service or our certificate management service to make that even easier for you. All this comes at no additional charge. The way Nitro Enclaves works is you get to launch an EC2 instance, and then you get to carve off some of its existing resources to run that enclave. We'll see that a bit later. So as I mentioned, all of this is built on the Nitro system. And the best way I find to kind of explain the Nitro system and get across what it's doing for security is to actually start with what life is like without a Nitro system and how different things are. So when we started EC2, we didn't have Nitro. We used a very traditional virtualization environment based on Zen, although we made extensive modifications and kind of fully owned the thing. And also there other cloud providers, other virtualization providers, and so on, still using this kind of traditional virtualization model of what you do is you take a physical server, right? And all virtualization means is we're going to take that physical server and we're going to make it seem like more than one server, more than one machine, right? They're going to be virtual machines. And traditionally, all of the virtualization just runs on that machine, right? You install a virtualization framework, something like Zen, and it essentially, it does something like hypervirtualization, where it'll say, let's have this machine, this virtual machine have this amount of memory, this virtual machine have this amount of memory. They can't read each other's memory. I'm going to give this virtual machine this CPU core. I'm going to give this virtual machine this CPU core, and they can't share them or anything like that. They don't see each other's cores. That's kind of the very basic, kind of primitive form of virtualization. All that's happening there is we're kind of coordinating what the physical CPU can do in terms of hypervirtualization extensions. And then there's the much more involved, more complicated virtualization of virtualizing things like the network, things like storage, right? So having this machine plugged into one VPC, having this virtual machine plugged into a different VPC, having this virtual machine get a certain EBS volume, this one gets a different volume, and so on. That's actually where the bulk of the work goes. And then there's also just kind of, basic housekeeping functions, like we need to make sure we've got security and a good operational posture and so on all happening. And on a traditional platform, all of this runs on the same hardware, and that has some downsides. It's running on the same CPU as the customer's instances. So stealing is taking a bit of the resource away in terms of what's available to the customer. And it also means that our security posture is based, primarily on hardening and operational security and a lot of paranoia. We're very good at that. We've got a large team who spend a lot of time making sure that all of that software is secure, but that's the primary approach, right? We've got to really scrutinize all that software, and although we do have some high-level defenses, everything ultimately is running on one box, so you don't have physical separation. And the AWS Nitro system is a little different. So AWS Nitro is actually a virtualization platform that's based on hardware that we design and build here at AWS. So we've got a division called Annapurna Labs, who actually design silicon and manufacture it. And we've actually built a standalone, piece of hardware, a system on a chip, an actual card that goes into our physical servers. And that card is essentially its own server. Like it's a separate machine with its own memory, its own CPU, not shared at all with the hardware that the customer instances are running on. And that's where we put the majority of our virtualization. We love this because running on a separate machine means we free up all those resources, right? We can now give the customers 100% of the 100% of the hardware's capacity, but it also means we get physical compartmentalization, right? The actual software that's doing like our network virtualization or our storage virtualization, it's running on a physically separate box with physically separate memory, right? Completely different memory DIMMs, CPU cores, and so on. It's a very high level of robust isolation, which is pretty cool. Because we designed and built it, we can do a few smart things. We can put in all the right functionality there that mean it does the best cryptography that our customers need. It's got all sorts of acceleration in there for cool things. We also got to architect it so that it matches our security requirements. So for example, nobody can log in to the Nitro system. It doesn't have interactive operator access. I'm an engineer, I work on EC2. I can't just go log into a Nitro system, right? It only exposes vetted, audited, secure APIs. They're kind of vended in a microservices way, and that's all it will let me do. So there's no like general purpose ability to just say, look at customer memory or something like that, because that wouldn't be secure. And the Nitro system itself, because of that physical isolation, it's self-compartmentalized, right? The only network that it has access to is something we call the EC2 substrate network, which doesn't include, general purpose or internet access, and a small set of restricted individuals ever have access to that network, and so on. So we get to have physical compartmentalization there. It's pretty cool. And then because it's a standalone system, we also get to solve some hardware attestation problems, right? So there's a kind of almost philosophical problem in security of how do you have a machine verify itself, right? If a machine is compromised in some way, how can you trust it to tell you that it's not compromised? And there's all sorts of complicated ways to try and do this that ultimately boil down to, well, we got to trust something that we ultimately put in silicon, but then what if there was a bug in that silicon or the CPU or microcode or whatever? It's a tough problem to solve. But with Nitro, because we actually have a separate piece of hardware attached, we can do it kind of from outside the box, right? So you got this little bit of distance and separation that really, helps resolve that philosophical conundrum. I should also say that the same team, Annapurna Labs, designed and built our Graviton 2 platform. And on Graviton 2, we've gone even further and we actually encrypt all of the memory as well. Like all of the memory without a customer ever having to do anything. It's just always encrypted. So these are kind of like the basic protections that Nitro provides, right? It gives us a platform that we can trust to run things on, and it gives us a very secure platform that enforces separation between customers and between customers' instances. It really makes sure that when we launch an instance for a customer and then launch another customer for a different customer, or launch another instance for a different customer, those instances can't read each other's memory, can't see anything that's going on between those instances, and that's all enforced, all the way down into hardware. And so how do we build Nitro Enclaves on top of this? How does Nitro Enclaves work? So the model with Nitro Enclaves is that you kind of pick from our wide array of instance types that are available. You just pick an EC2 instance type, more or less as normal. It has to be a Nitro capable instance type, but the list of those are documented and up on our website. You pick an EC2 instance, type and size. As long as it's got more than 2 vCPUs, you're good. And then you run that instance. And then when that instance is running, you log into it as normal or with automation. You can then use the Nitro CLI, our command line utility, to launch and run an enclave. And when you do that, you tell us a few things. You tell us what enclave image you want to run inside that enclave, and you tell us how many dedicated cores or vCPUs you want to provide to that enclave, and how much memory you want to provide to that enclave. And what happens at that point is a few things. So, you start off with your instance, you run this command, and what the Nitro hypervisor actually does at this point is creates a new virtual machine, right? So it creates a new virtual machine with its own ring-fence memory and its own CPU cores from the ones you kind of donated from the instance, and then it spins up and runs the enclave image inside that. And I want to emphasize here the compartmentalization, the separation between your EC2 instance that launched an enclave and the enclave or any other instance running on the same physical hardware is as robust and as strong as the separation between any 2 customer instances. So the memory is just completely inaccessible, and you can't see what's going on inside that enclave, even from the instance that launched it, even as root on the instance that launched it. Running enclaves does require a kernel module that we provide to install in the instance, and all that kernel module is doing is kind of helping the kernel realize, oh, this CPU core that I knew about a minute ago, or this memory that I had a minute ago, that's going to disappear. That's going to be donated to an enclave. That's all the module is doing. It's not doing anything security. All the security enforcement happens in Nitro itself, and it's all isolated with the Nitro virtualization and those simple, robust in-hardware virtualization extensions. And as someone who works on cryptography, there are other enclave implementations that use memory encryption as their mechanisms to kind of isolate some application memory from say, a parent. I personally prefer this approach where the memory is just completely gone. You can't even access it. It's like it's not even there. And that's because when you encrypt memory, it's encrypted. It looks like noise, but you can still see things. You can still see how much of that memory is being used. You can see patterns of access and changes in that memory. And sometimes, depending on the implementation as well, the memory is still malleable, right? You can still make changes to it and mess with the application and then see how the application behaves and what you can learn from that. All of those attacks go away in our model. The memory is simply not there. Just very, very simple, very robust. We like to use things that are, old, reliable, and boring sometimes when we're working on, foundational security. And then this is definitely one of those cases. So when we spin up the enclave, it's highly, highly isolated, right? We just created this virtual machine. We booted the image in it, but that environment has no durable storage. It has no networking. It's got no interactive access. It's got none of the ancillary services you might expect with an EC2 instance, things like DNS, NTP, the instance metadata service. They're simply not there, right? The instance is extremely constrained. It's got just very little capabilities. It's kind of this dark box in which you can perform compute and by default can't reach or talk to anything. The enclave images themselves, our reference examples, and then we also encourage customers and vendors to follow this pattern. They're extremely minimal, extremely stripped down. You want a very bare bones kernel. You want a very, very small user space, not very many applications in there, nothing like a shell. and so on, because you want to keep the surface area as small as possible. In fact, we hope we may see people building enclave images based even on library OSs or unikernels, right? Extremely stripped down, minimized environments. We've got tooling to help build these enclave images, starting with Docker container definitions. You can kind of think of the enclave images as kind of like a small version of an AMI or an AMI, and you know, now that it's 2020 and Docker is cool and containers are common and popular, we just thought it'd be a nice, convenient way to be able to collect and organize your software, you know, into a container definition and then produce an enclave image from that. That doesn't mean to use enclaves you have to run Docker or even use containers or orchestration frameworks. It's just kind of a super convenient packaging framework. I like that anyway. And so you build these images. You can also sign them. So we support code signing of enclave images. So when you create one, you can provide the signing key, and we'll compute and produce the signature on that enclave image. You produce it, and the tool at that point tells you, here's a bunch of checksums for your image. I'll come back to those in a bit. So that's how you produce the image. We've seen how you launch the image. But I just told you, when you run that image, you get this virtual machine where everything is dark, right? How do you actually talk to things? How do you do anything, right? Well, we provide a few facilities. So inside the enclave, and also on the instance that launched it, we create this thing called a VM socket or a VSOC. And this is, you can kind of think of it like TCP, like a local form of TCP. I think of it almost like a virtual serial cable just connecting two computers. And you can do this TCP-like communication between your instance and your enclave. But unlike TCP or IP, that communication can't be leaked, spoofed, or intercepted. It's a local-only networking format. But that still provides you this really convenient experience where your instance and your enclave kind of communicate to each other just using like message passing or RPC or REST or microservices or whatever cool name we're giving this year to, you know, sending requests to another machine and getting responses back. Extremely old programming paradigm, works in any programming language or framework. Then there's some more facilities on the enclave itself. So we provide an entropy service to the enclave, and that's because when you launch an enclave, it's so dark and it's got access to so little, like it's got no storage system, no networking system, that the usual way kernels use to create randomness just aren't there. Normally they measure things like network interrupts or disk interrupts, and they're just simply not there. And so to fill that gap, we've got this core service that you can essentially just ask from the Nitro system, just give me some random data. We've also got the CPU-based randomness available, so if you want to use RDRAND, that works too. But just there's a simple facility. And then we also have an attestation service. And so the way the attestation service works is that when an enclave image boots, an application inside the enclave creates a public-private key pair. And that key pair live and die with that kind of instantiation of an enclave. When that enclave shuts down, poof, they're gone, right? And you might share the public key with others because it's public, but the private key never leaves the enclave, never goes anywhere. And so the enclave supplies this public key and optionally a nonce, so that's a number used once. It's used for enforcing uniqueness constraints in some protocols if you need it. And it provides that to the attestation service. And then the attestation service replies with an attestation document. And that document includes things like, well, here's the nonce and public key you just gave me, but also things like, well, here's the checksum of the enclave image. Here's the checksum of the kernel, the application. Here's the key that's inside the enclave image. Here's the instance it's attached to. Here's the role that instance has. Here's when it was launched. Here's what the current time is. All these kind of details and more are in there. And the attestation document is then signed by a key that is part of the Nitro PKI system. And so we're publishing that. Our root PKI keys are published. Anybody can verify an attestation document. And when they verify an attestation document, they can be sure that only an enclave running on a Nitro system got that attestation document, right? And so they can then encrypt something to that public key, and they know only the enclave can decrypt it, right? Any service can do this. It could be your service, could be a vendor's third-party service. It's completely open for anybody to use. Now, to make this easier, we've also got first-class integration with our key management service and our certificate management services, so that you can get keys and certificates into an enclave using those two things. Now, at this point, you may be wondering, well, how, if an enclave has no networking, how can it do something like talk to KMS to get a key or talk to ACM to get a certificate? So the way this works is we actually have a helper agent that runs on the EC2 instance and just forwards encrypted traffic, end-to-end encrypted traffic between the enclave and that service. So when the enclave needs to talk to, say, KMS, it actually uses a TLS or SSL connection that's initiated inside the enclave, and then it kind of gets tunneled or forwarded by that helper agent to KMS. And so all the helper agent ever sees, right, is this encrypted communications. We've got end-to-end encryption here. The instance can't see inside that connection, can't spoof KMS or somehow intercept that connection, and can't really mess with it. And I should say, unlike kind of memory encryption, which is kind of a very evolving, not so mature field, this kind of network encryption of just sending traffic encrypted over a network is an extremely mature field of cryptography. It's probably the oldest application of cryptography and has all sorts of robustness built in. And so that, again, we're back to boring, old, fairly reliable systems that mean the instance, even though it's relaying this information, never actually gets to see the plain text, which is obviously extremely important. And so, if you want a good example of this, you can look at our enclave applications that do this. Very, very easy patterns to copy and follow. This overall model means that AWS is taking responsibility for the isolation between enclaves and instances, which is a really hard part. We do that with our hardware security and our operational security model, but customers take responsibility for making sure that the application inside the enclave is secure, right? So they have to make sure that it doesn't have any vulnerabilities that are exposed to the parent instance over that VSOC or anything else that could be possibly abused. Good example of that is a side channel. So, for example, if you gave input A to the enclave, it takes 5 seconds to process, and input B to the enclave, it takes 10 seconds to process. Well, now someone from outside can tell which input was given, even if they're both encrypted. So we've got some examples of this. Our top example of folks using an enclave is for sensitive data processing. And so the way this works, you create an enclave image that does some kind of sensitive data processing. For example, it might look at a sheet of data, and that data might be sensitive, but it might release some information like, well, here's the overall count of that data. And so you look at that application, you do a code review, you make sure that's all it does, you're happy with that, it's very secure. You build it into an enclave image, you sign that, and you build that enclave image, and then you can just go run it, and you can release material into that enclave using the patterns we just covered with KMS. You can actually configure a KMS policy that says only an enclave with the following checksum can actually access that data, or only an enclave that was signed by a particular signing key can access that data. We've got our own example of this. The ACM for Nitro Enclaves application basically does exactly this pattern. So it's an enclave application that you go to ACM, you create a certificate, you associate that certificate with an IAM role, and then what you can do is say any instance with that IAM role can now run an ACM for Nitro Enclaves enclave, and it will be able to access that certificate. And what's happening under the hood is, we're using KMS policies with that capability to actually relay all the information and just make it work. Another example is multi-party collaboration, right, or multi-party computation, as it's sometimes called. And so you've got, say, two customers who each want to look at each other's data sets to a certain extent, but they don't necessarily trust each other to here, have my full data set. So what they can do is they can each look at an application and say, this application does what I want. It looks at our two data sets and tells me some, say, intersection or some safe knowledge about those two data sets. And then, one customer creates a policy that says, okay, well, that image can now access my data, and the other customer does the same. And at that point, anybody can run this image. Doesn't matter. One customer could run it, another customer could run it, or a complete third party could run this customer image. But either way, only that attested customer image with that checksum will be permitted to access the data, because that's how the two customers have configured it. And then our final example is, well, what if I don't want to protect a data set? What if I want to protect an application? Like maybe I've got a machine learning model I've invested thousands and thousands of training hours in, and I want to keep it protected. That's actually extremely similar to the first case, except instead of encrypting the data set, we encrypt the application, right? And so we just encrypt the application in the enclave image, and then when we're starting up, we have a little bootstrap script that says, well, I need a KMS key to decrypt that application. Does that based on some attestation policy, and we're off to the races. At that point, the intellectual property is fully protected. All of our examples are open source. You can go see on GitHub. You can see our kernel modules on the Linux kernel mailing list and so on. You can see exactly how we're doing all this. You can take those examples and build your own, extensions and cool things on top of that. We're excited to see what people have been building already. We're excited to see what else people will come along with. In terms of takeaways, hopefully, if you take nothing else away from this presentation, I think the biggest thing I want you to realize is that the interface for using enclaves or Nitro Enclaves is a very adaptable and convenient, right? You can get going and running in any programming language or framework. You just have to be able to structure your workload as, I'm going to take my sensitive data processing, I'm going to run that in a standalone application, and I'm going to use requests or RPC as a pattern between that and the rest of my application, which any development team can control themselves at pretty easily, which is nice. You don't have to think about memory transactions. You don't have to think about any of that complicated stuff. Thank you for listening. Thanks for following along with this talk. I'd be super grateful if you have the time to fill out the session survey. It helps tell us what you're interested in, both for refining future versions of this talk or for other talks we should be giving. It's just a goldmine of information for us. Thank you again.